our lesson. All right. So last class, we got a definition of what an object is and what a class is. Today, we're going to investigate how we can use our classes to actually create objects, how we fill in the blueprint. So our rough pseudocode class that we talked about last time was our rectangle class. We said that every rectangle must have a width and a height, and then the area and perimeter of a rectangle can be calculated using its width and height values. So there was our blueprint for our object. There's our class. And now let's look at what that would actually look like if I fully wrote it out in my code. Boom. Look at all this code. I have public class rectangle and my private int width and height. I have this public rectangle thing. I have my get area, get width, get height, and string. So for right now, we're going to focus on this chunk. We'll talk about all of this at a later point in time. So let's zoom in on that. We've got our public class rectangle and our public int width and public int height. We kind of already talked about that last class. Here is where we are declaring our class's instance variables. Here's where we're saying these are the variables that are going to be part of this class, part of any object that we create when we make it. Doing this is going to declare these variables, but it will not initialize them. And those two variables, are width and height, will be initialized when we actually create an object of the rectangle type. So this thing here is public rectangle is called the constructor of the class. It's also known as the signature of the class. And you'll notice that the constructor has the same name as the actual class itself. So we have our rectangle and we have rectangle here as well. So over here, we again have the name of our constructor should always match the name of the class, so that we know exactly what the name of the constructor should always be. Here we have the, wow, that rectangle does not fit at all. We have the parameters being sent to the constructor. And these two variables, my rect width and rect height, are what I'm going to use to initialize the class's instance variables. I need to make sure that I clarify what types both of my parameters are here. If I don't include those types, I'm going to get an error. So once I have finished writing my constructor, this is what creating an object is actually going to look like. Actually, here, let's go back just a little bit. When I get those two pieces of information, my rect width and rect height, I'm going to save those into my actual class variables, my width and height values. So that's how I'm going to initialize those two variables, is with these two values that I got as parameters, just the information that I'm getting in my rectangle constructor. Okay, so once I have finished writing the constructor, I can create a variable of the rectangle type. Just like any other time I'm declaring a variable, I need to say what type my variable is going to be. So we're making a rectangle type variable. Then the other part of our declaration is the name of the variable. Our variable myRect here is going to be an object because it's a variable with a class as its data type. So myRect is going to be a rectangle typed object. So there's our declaration. On our right side, let's look at our initialization. here we have the new keyword, and we need to use this special new keyword when we are initializing an object. So whenever I create a new object from a class using a constructor, I need to use that special new keyword. The single exception to this is with a string. Java handles those in a special way, and we can just say that a string equals a string literal. We don't have to use the new keyword here. For any other object we create, though, we need that new followed by our call to the constructor. This is just saying, all right, constructor, do your thing, finish initializing our object. So we have our rectangle constructor name, and then we have our two parameters, our actual parameters. So let's look at a little bit of a difference between formal and actual parameters. Formal parameters, those are the ones that we're defining up in our constructor in our class. Actual parameters are the values that we are giving to our constructor when we're making an object. So with my rectangle 1515, they're going to go in order. So my first parameter, my first actual parameter is going to get fed through into my first formal parameter. My second actual parameter is going to get fed into my second actual or second formal parameter. So I'll get 15 and 15. And then width is going to equal the value stored in rect width. So width will be 15. Height is going to equal the value stored in rect height. Height will also be 15. So we will initialize our width and height for our rectangle as 15 and 15. I realize I've been talking very quickly. Does anyone have any questions about what I've talked about so far? Okay. So a few things to be aware of. First, the types of the actual parameters need to match the types of your formal parameters. So I can't make a rectangle and try to pass a string because I'm not allowed to put a string in an int typed box. Just like in a regular variable assignment, you're not allowed to assign a value of a different type than what we declared. So we'll get that incompatible types error when I try to give an invalid type as an actual parameter. And second, the number of actual parameters needs to match the number of formal parameters. So if I try to create a rectangle and only give it one number, Java is not going to know what to do in that situation. I'm expecting to get two numbers. If I only give it one, Java is going to throw this kind of error. This constructor cannot be applied to the given types because our number of values, our number of parameters doesn't match. It doesn't know how to actually apply that one value to that multiple slots. So if you have two parameters, you can't use one, you can't use three. You need to use exactly the same number in your actual parameters as formal parameters. Do those stipulations make sense? All right. So let's look at an actual example. Here we have our student class. Our student class has these three attributes. We have our first name and last name, which are strings. We have a grade level, which is an integer. And then here is our constructor. We are our student, it matches our class name. And we're getting three parameters, fname, lname, and grade. And we want to make sure that these have different names than our actual class attributes, because we're going to be assigning our proper class attributes with whatever value is in these parameters. And if they have the same name, Java is not going to know what you're trying to work with. So you want to make sure that you have probably similar names, like first name and F name. You can tell which ones are supposed to go with which, but if you have exactly the same name, Java is going to be confused. So we have our first name and F name, last name and L name, and then grade level and grade. So our actual class values are going to equal whatever value was passed into my constructor. Whatever value was given to my constructor is going to be saved into my instance variable, my first name attribute. And then down here, we have this toString function, which is just going to turn our object into a string so that we can actually print it out nicely. So if I look here at my actual student tester code, we have two classes here. My student tester class is going to create two student typed objects. We have our student object Alan, which is going to equal the new student with first name Alan, last name Turing, age, or not age, grade is 11. And then student Ada equals new student constructor, first name Ada, last name Lovelace, grade 12. So when I print Alan and Ada, let it think, I will see exactly what is in that toString. And when we are working, at least for this class, the toString will be defined for us. You won't need to worry about that. But we can see Alan Turing is in grade 11, Ada Lovelace is in grade 12, because that is the values that we use to initialize that object. Does that example make sense with what we talked about today?